All right, everybody. Monday, first day of a 2-week shutdown from school, which is kind of cool, but the school has asked that I keep the curriculum moving forward until further notice. So with that, thank you for the ones who have started working on the assignment. If not, please get to it. This is to kind of go along with what you've done so far. Very similar to what we do in the classroom. So anyway, what we're going to cover today is we're going to just real briefly discuss conductors, wire, and cable. And then we're going to look at stranded versus solid. We're going to brief discussion on grounding. We'll discuss copper versus aluminum, or copper and aluminum. And then we will do a quick conversation about insulation. Then conductor size, and we will wrap it up with how the code book defines dry, damp, and wet. So, with that, the first thing we'll discuss is we have conductors, wire, and cable. Okay, so the conductor is the metal that allows electricity to travel. All right, wire is the insulation and the conductor together. All right, and then a cable is two or more conductors or wires in a protective sheathing. Okay, so to put it simply is right here I've got some 14-2 NM cable, which I typically call Romex. So we have the metal conductor, the wire is the metal conductor and the insulation, and then because we have the two plus a ground in a protective sheathing, that makes this whole thing a cable. Okay, show it down here too. So I have the metal conductor, the wire is the insulation and the metal conductor, and then the cable is the two or more wires in a protective sheathing. The one thing that I should say is that if a wire is a ground or bare, is meant to be bare, that'll be considered a wire as well. Not necessarily just the conductor, because this is meant to be bare. Moving on from there, the book says, regardless of the wiring system used, it is important to have a continuous ground throughout every part of the system and every circuit. So I've been going over that with you guys since the beginning, right? That ground is our system safety or our backup. Typically all we need is the on-grounded conductor to carry the electricity in. We need the grounded conductor, which is the neutral, to carry it out. But then that grounding conductor is a backup to the neutral should we lose the neutral for any reason. Or the grounded conductor. So, yeah. Now we're going to do a brief discussion on conductors. Copper and aluminum conductors are used in residential wiring. That is true. However, within the house, you're pretty much only ever going to install copper. Now, the service coming to the house, which is the bigger wire with our meter and our service entrance, that will often be, or most commonly be, aluminum because it's cheaper. Look at this here. We have copper is the most common conductor material for electrical wiring. It is strong and resists oxidation, corrosion. Aluminum, on the other hand, has a good conductance. However, it is subject to problems as a result of oxidation and expansion. So aluminum has oxidation from expansion, or oxidation, which is a problem. If you've ever seen it, aluminum turns it into a powdery substance, not good. And then expansion and contraction. Hot and cold, aluminum expands and contracts more than copper, and that makes it a bad thing. Wherever you might connect aluminum wire, it's very important that you use a thing we call no-lox, which is like a greasy substance that is put on to the terminals and to the cable or to the conductor that helps it from oxidizing and causing corrosion. Very important. And I retract my earlier statement. It is possible that you could feed your bigger air conditioners, like if you have central air, or maybe your stove or something with aluminum, but the same rules apply. It's extremely important that you install no-lox in those situations to help prevent the corrosion that I'm speaking of. We now go to insulations. All right, conductors that normally carry current must have a non-conductive covering of insulation. This insulation can be made with a variety of materials. The type of wire used depends upon the situation and the environment where the wire is to be placed. The most common insulation is used in residential electrical wiring is thermoplastic made from PVC. It then goes on to say that the insulation properties of wire are indicated by a lettering system, which we'll go over in a second. That lettering system, the most common that I've ever used ever in my life, is THHN. The T is thermoplastic, and then also says flame retardant. H is heat resistance. HH would be high heat resistance. The W would be wet or suitable for damp or wet locations, and the N is nylon jacketed. Contains a tough outer coating of nylon protector to protect wires when they are pulled through a conduit. So if we go back to this THHN, that T is thermoplastic, HH is high heat, and N is nylon jacketed. That's simple. From there, if you go to the book, you will see that you have all of these different kind of types of insulation that can be found on wire. We'll talk more about that stuff soon. Conductor size. Oh, this one's fun. All right, for conductor size, we are going to be discussing American wire gauge. All right, the smallest wires in residential wiring are 18 to 1 American wire gauge, according to our book. The larger the number, the smaller the diameter. That is true. After the American wire gauge, the wires increase in size from 1/0, or this 1-0, which that -0 is considered or pronounced aught. So that 1/0 to 4/0. Wires larger than 4/0 are designated by the KCMIL, which is 1,000 circular mils. A circular mil is the area of a circle with a diameter of 1/1000th of an inch. Sometimes KCMILs are noted with the symbol MCM, using the Roman numeral M, which means 1,000. So no matter what way we look at this, it's KCMIL is 1,000 circular mils. MCM is the CM is circular mils. That M in front of it is the Roman 1,000. So no matter what, it's 1,000 circular mils, which is something. All right, that's important. If we look in the book here on the chart, this will help bring it into place of how messed up our system is. It says over here that the larger the number, the smaller the diameter. So 14, right, is a pretty big number. 14 is what we use in the shop. So we have 14, then 12, then 10, then 8, then 6, then 4, then 2. All right. So right there, they're all even numbers. Counting backwards, the number gets bigger. So 14 is smaller than 2. Okay? But then for some reason, we have all these even numbers. Then all of a sudden, they throw a 1 in there. From there, we go to 1/0, 2/0, 3/0, and 4/0. Okay? Increasing in size. It's important. All of these are American wire gauge. AWG, AWG, AWG. So I would put a number 14, a number 1, a number 4/0, whatever it may be. Then we jump to this KCMIL, or MCM more commonly, and that will be 250 and 500, and that is a measurement, if our book says down here, which I didn't highlight it. The reason the larger wires are specified in KCMIL instead of diameter is because KCMIL is a measurement of a wire's cross-sectional area. The area of the wire is important because it is a factor in determining the ampacity of the conductor. The last thing I want to go over is kind of common sense. How the code book defines damp, dry, and wet. Okay, so a damp location is right from the book is locations protected from weather and not subject to saturation within water or with water or other liquids, but subject to moderate degrees of moisture. So the book will then go on to say that under a porch, under a roof, but open to the elements, will be considered a damp location. A dry location is a location that not normally subject to dampness or wetness. I'm not even going to give an example for that because we should know what a dry location would be. Lastly, wet location. Installations underground or in concrete slabs or masonry in direct contact with the earth in locations subject to saturation with water or other liquids, such as vehicle washing areas and unprotected locations exposed to weather. So I think the book then goes on to say, for an example, if I have an exterior light on the side of my house, that's going to be a wet location. A damp location could be the light in my shower, okay? Stuff like that. So it's very important, but I really think that that's kind of common sense. You're damp, dry, and wet. So what we went over was our conductors, all right? Conductor, wire, cable. We have solid versus stranded. I don't know if I actually did go over that in the video, but come on now. Solid and stranded. The grounding, all right, must have that continuous ground. Continuous ground. Then we have the copper versus aluminum. Copper more common inside the house. Bigger wires will often be aluminum because it's cheaper. However, if you install aluminum, you have to watch out for expansion and contraction, and you have to watch out for oxidation, so you must use Nolax. Insulation, most common, THHN, but we'll go over more about those lettering system and all that. The important thing is that you understand, or that you know that T is thermoplastic, H is heat resistant, H is high heat resistant, W is wet location, and N is nylon jacketed. Then we have the conductor sizing. Nothing you can do but kind of remember that, or memorize it. 14 smaller, 1 is bigger, 1/0 to 4/0. Then we go to the MCM, or the case of mils. You're going to need to know that stuff, though. That is very important. And then we did the code alert with the damp, dry, and wet. So I want to thank you guys for watching the video. Any questions, please contact me. I'm doing my best here. Be nice to me. I hope you're all doing well. Hopefully we'll be back in class soon. And be safe.